Welcome to Mapping in 3D, a step-by-step guide to using FieldPapers for 3D mapping in OSM. In this video, we're diving into FieldPapers, a powerful tool that makes field mapping easy and efficient. Whether you're looking to capture 3D mapping data or contribute other valuable information to OpenStreetMap, FieldPapers provides a seamless way to bridge the gap between paper and digital maps. I'll guide you through everything you need to know, from creating printable maps to uploading your field notes and enhancing OSM with real-world details. Let's go ahead and get started. FieldPapers is a free tool that helps you bridge the gap between fieldwork and digital mapping. You can create printable maps, annotate them by hand with details like building heights and roof shapes, and then upload those maps to align with digital base maps. It's especially useful for offline fieldwork and works seamlessly with platforms like OpenStreetMap. It's a powerful but easy to use tool for 3D mapping workflows. So why choose FieldPapers? First, it's incredibly simple and doesn't require technical expertise. You can fully customize your maps to fit your needs, like mapping 3D features. It's offline friendly, which is a game changer for fieldwork in remote areas. And finally, it allows you to share your data directly with OSM, making your contributions part of a global mapping effort. Here's a quick overview of the process we'll cover in the demo. First, we'll create a map atlas of the area we want to work on using FieldPapers. Then, in the field, we'll annotate it by hand, marking 3D features like building heights or roof shapes. After that, we'll upload the annotated maps to FieldPapers to georeference them. Finally, we'll use those georeference maps to edit and upload data to OpenStreetMap. Now, let's see FieldPapers in action. To begin, I'll open my browser and navigate to fieldpapers.org. Once there, I'll click on Make Yourself an Atlas. Using the search bar or manual navigation, I'll locate my area of interest. For this demo, I'll focus on a portion of New York City in the United States, an area I'm familiar with and I'm interested in improving the local data nearby. I'll adjust the zoom level to capture the right amount of detail. Since New York City is highly dense, I'll zoom in significantly to reduce the number of buildings in each grid square. Depending on your area of interest and the size of your mapping team, you can customize these settings to fit your needs. Additionally, the number of columns and rows can be adjusted to align with your project's scope. For this demo, I'm focusing on these two blocks, so I'll reduce the number of columns to just one to better fit my area of interest. Once my area of interest is finalized, I'll name the atlas New York City 3D Mapping. You also have the option to add a note section by checking the corresponding box. This can be useful if you prefer to take detailed annotations. However, for this demo, I'll leave it unchecked. I'll keep the paper size set to letter, but switch the orientation to portrait to better fit my mapping area. FieldPapers also offers different base map options, but I'll stick with the default OpenStreetMap for consistency. Once satisfied with these map settings, I'll click Make Atlas. After processing, I'll download the generated PDF, which will serve as my printable map for field annotations. Before printing, I'll carefully review the map to ensure all key landmarks and features are clearly visible. Now that you have your printed map, it's time to prepare for fieldwork. Before heading out, I like to create a shorthand reference sheet to streamline my annotations. Here you can see a list of tags I plan to collect for the buildings in my area of interest. Beneath each tag, I've developed a shorthand code to make field annotations quicker and more efficient. For example, I've shortened buildings:"levels" to B:"L" by taking the first letter of each word. I've applied the same pattern across all the tags for consistency. Some of the other key tags I plan on documenting are roof shape, building material, building levels, levels underground, building color, and building usage. Consider carrying a printed copy of the OSM Wiki tagging page or keeping it accessible on your phone to ensure accurate tagging while you're out in the field. Feel free to create your own shorthand codes in a way that makes sense to you, but be sure to stay consistent to avoid confusion when uploading your data to OSM later, and always remember to use clear, legible handwriting. Before heading out, I always bring a clipboard to make note-taking easier. I also bring my phone, which I often use to take photos of mapped buildings. These photos serve as a valuable reference in case I need to verify any annotations later. I also pack a pen and a backup and a portable charger. The first building I'm mapping in the field is a classic New York City brownstone. On my printed map, the building numbers are labeled, so I start by checking the number on the door of the building to make sure that I'm mapping attributes for the correct building. First, I'll start by marking this building down as residential, using my shorthand B = R. Next, I count 5 levels, so I record that as B:L = 5. After crossing the street for a better view, I notice there's one underground level, likely a basement, so I will add that to my notes. The roof appears to be flat, so I mark R:(S = F for the roof shape. I can't determine the roof color from where I'm standing, so I leave that field blank for now. The building material is clearly brick, so I make a note of that as well. Finally, I take a photo of the building. This will help me later when I use an online color picker to identify the exact building color. For now, I just note on the map that a photo has been taken for future reference. The second building I'm mapping is this taller apartment building on the corner. First, I mark the building on my map and double check that the building numbers match up, just to be sure I'm mapping the right one. I start by noting that it's a residential building, using my shorthand B = R. Then I count 7 levels and record that using my shorthand for building levels. Since I can't tell how many underground levels there are, I mark a question mark to indicate that I'm unsure. From where I'm standing, I can see that the roof is flat, so I write R:(S = F, F being my shorthand for flat. I can also tell that the building is made of concrete, so I note that down using B:(M) = concrete. Finally, I take a photo of the building. This gives me something to reference later while mapping and also helps me identify the building's color once I'm back at my computer. As you can see, I'm running out of space within the building outline on this page to write down all of the characteristics of this building. Since I'm only mapping a few buildings on this page, I use an arrow to show which building these notes refer to. However, if I were planning to map every building on this page, I'd likely bring a blank sheet of paper and label the buildings using their building numbers. That way, I'd have plenty of space to record all the details for each one. Once your annotations are complete and you're back at your computer, take a well-lit, high-quality photo of your map. Make sure the entire page is fully visible and that all details are clear. Next, go to the FieldPapers website and click on Upload. Select your annotated map photo and upload it. FieldPapers will process the image and align it with the digital base map, effectively georeferencing your annotations. From here, you can either download the GeoTIFF or choose to edit your area directly in OpenStreetMap using your preferred mapping platform. For the purpose of this video, I'll go ahead and make edits using the ID editor. By clicking the ID editor button, I'm taken directly to the editing pane in OpenStreetMap. My annotated FieldPapers map is automatically loaded as the background. As you can see, my handwritten building notes appear in the editing pane, which makes it easier to update the tags. This also means other members of your mapping team can contribute to tagging without needing the physical copy of the map. Looking at the map, I notice that the FieldPapers image and the OSM features aren't perfectly aligned. That's common. To fix this, I open the background panel on the right-hand side of the screen and adjust the imagery offset. Once I've aligned the imagery and the OSM features as best I can, I select the building I want to update. I double-check that the building number matches the one I took notes on in the field. First, I update the building tag to mark it as residential. Then, I scroll down and add a new tag for building levels, setting it to 5. I repeat this process to add tags for underground levels, roof shape, and building material. For the building color, I'll upload the photo I took in the field to an online color picker tool. Then, I'll copy the hex code and paste it into the OSM tagging box, making sure to include the hashtag symbol. Once I've added all the tags I recorded in the field, I go ahead and save my edits. Make sure to include a change set comment describing what you updated. In this case, I note that I added 3D building attributes like levels, material, and roof shape based on my FieldPapers survey. For the source, I specify that the information came from a field survey, and I mention FieldPapers directly in my comment above. After that, I upload my changes to OpenStreetMap. And that's it! I've successfully tagged 3D building attributes in OpenStreetMap using FieldPapers. Before you get started, here are some best practices to keep in mind. Use clear and legible annotations so that your notes are easy to interpret later. Reference landmarks for accuracy when sketching features. Double-check your map's scale and layout before printing to ensure it's suitable for your area of interest. Lastly, when uploading your data to OpenStreetMap, follow their 3D tagging standards to maintain consistency with the platform. That concludes our session on using FieldPapers to capture and upload 3D features into OpenStreetMap. We'd like to extend a big thank you to Cesium for their support in bringing this video to you. If you found this tutorial helpful, be sure to explore our 3D mapping playlist for more in-depth videos and tips. Don't forget to like this video and subscribe to our channel for more exciting content on mapping. Thanks for watching and happy mapping!